Few things are more mesmerizing than watching a campfire, especially when it's filmed in slow motion. Take a careful look at this burning wood, and you'll see that it's not actually the wood itself that's burning, but the gas products given off by the heated wood. It is evidenced by the fact that you can follow the wisps of flame all the way up into the gases being given off to the right of the screen. Really, what we're seeing is light giving off by electrons as they move around during a chemical reaction. In this video, we're going to talk about the basics of combustion, and then specifically look at some interesting aspects of wood combustion and the difference between wood and charcoal as a cooking fuel. Hello, chemistry students. The basic definition of combustion is the exothermic chemical reaction of a substance with oxygen. So combustion gives off heat. I think we know that. Usually combustion is only used to describe reactions of oxygen with organic hydrocarbons. We've learned about these examples like methane and propane. Other substances will react with oxygen. We know that iron will react with oxygen to form rust or iron 3 oxide. This normally is called an oxidation reaction, though, with iron giving up its electrons to oxygen, and not a combustion reaction. Combustion reactions are limited to things like methane reacting with 2 moles of oxygen gas to produce carbon dioxide and 2 moles of water. The more complex the hydrocarbons, the more carbon dioxide and water is produced, but also the more likelihood there is of impurities. This particular reaction is much like the burning of natural gas to heat a home, which is considered to be an environmentally fairly clean process. But as you get into longer hydrocarbons with more complex molecules, ones that may contain nitrogen or sulfur in their molecular structure, you can start to produce all sorts of other byproducts like nitrogen oxides, sulfur oxides, and even in a shortage of oxygen in the environment, carbon monoxide. All of these substances are rather undesirable and are often called pollutants. The burning of a hydrocarbon cannot get around carbon dioxide and water. The main goal of efficient hydrocarbon systems is to try and minimize the production of the other pollutants while only producing carbon dioxide and water. The problem with this, obviously, is that you can't avoid producing carbon dioxide when you burn a hydrocarbon. Therefore, no matter how clean the hydrocarbon process might be, it's still going to produce the greenhouse gas carbon dioxide. One common use of combustion is in the burning of wood. This wood is commonly used as a source of heat or for cooking. One thing people don't always realize is that you don't want to cook food directly over burning wood. Wood is a combination of complex organic molecules. A lot of it is cellulose, which is sort of similar to some sugars. But when you heat up wood, those organic molecules start to decompose in a process called pyrolysis. When a piece of wood is heated, it begins to undergo thermal decomposition, meaning that in the presence of heat, the complex molecules of the wood will begin to break down, producing simpler substances. Some of these substances in wood are flammable gases. The pyrolysis products eventually will reach a temperature at which they ignite. The ignition begins chemical reactions with oxygen that we can observe as the electrons move around, giving off light. That is actually the flame that we see. The combustion products then are produced from this reaction. This diagram of a lit match shows the progression from the pyrolysis products through the combustion and eventually the combustion gases. A visual example of the production of flammable gases from the heating of a hydrocarbon is the classic example involving a candle. This candle had been lit for several seconds before being blown out. The still warm candle waxes, however, are producing flammable vapors that can be seen reigniting from the nearby ignition source, traveling backwards along the gas propagation until it reignites the candle wick. Something similar happens when we overheat a marshmallow, toasting it on a campfire. Initially, the marshmallow, when exposed to heat, will undergo caramelization. Caramelization is familiar to us by the nutty smell of the Maillard reactions along with the brownish color of the sugar. If that reaction progresses, however, eventually it undergoes carbonization, producing the black charcoal that is a burnt marshmallow. In the process, though, there are flammable vapors given off, and we can observe the wood fire actually grow a bit as it encounters those flammable vapors, flashing backwards and setting the marshmallow on fire. I don't know about you, but I prefer my marshmallows to be rare and not well done. The problem with cooking directly over wood is that some of those pyrolysis products actually are not overly good for your health, and you wouldn't want to have those chemicals absorb into the food that then you're going to consume. We're better off to use wood that's gone through the process of carbonization. If you take pyrolysis to its extreme, it becomes a process that we call carbonization. So carbonization is something that we would use, say, to produce charcoal. So you may not be able to see it in the camera, but this charcoal looks a lot like a piece of wood, very similar to this. And in fact, if I look closely, I can see the wood grain in the charcoal. Now, some of you might say, well, gee, that doesn't necessarily look like charcoal that I've seen. I've seen charcoal that looks more like this, the little briquettes of charcoal. These briquettes are not pure wood. If you look on the websites of some of the charcoal briquette manufacturers, they'll say that these contain other bits of material. There are binders that hold it into this nice briquette shape. Sometimes there's a little bit of even things like coal dust mixed in with it. There's kind of a fun story about the origin of charcoal briquettes. They actually were invented by somebody that was a relation to Henry Ford. And when Henry Ford was building the Model Ts back in the early 1900s, those cars were built with wooden bodies. So Henry Ford needed a good supply of timber up in Michigan, and he also needed a place to dispose of the leftover wood scraps. Henry Ford actually was fairly environmentally friendly because for him it made good business sense to use everything that you had. One of Henry Ford's relations had developed a process to turn wood dust and wood scraps into charcoal. The name of that relative of Henry Ford's was Kingsford. A little known bit of trivia there. But as far as taking a piece of wood like this and turning it into charcoal, you basically take wood and you bake it at very high temperatures. And I will give you a link to another video that kind of talks about the historical process of charcoal making. But you take wood, you bake it at very high temperatures for a long period of time, and that allows all of those undesirable organic compounds to escape, leaving behind what is mostly pure carbon. And that pure carbon burns very cleanly and is a much better source of fuel to cook food directly over than raw wood would be. We all know many different applications of combustion in modern society: heating, cooking, transportation, and even in various stages of industry. Combustion is a very important reaction. It's not that hard to understand, but the variety of potential combustion reactions is enormous. Hopefully you learned something out of this. We'll follow up with this in class. Have a good day.